For over a millennium, humanity operated within a specific architecture of the cosmos. Common sense suggested the Earth stood still, while the sun, the stars, and the planets spun around us in predictable, perfect circles. The Catholic Church backed this Earth-centered map with absolute, unquestioned doctrine, making the geocentric model both a scientific standard and a matter of divine law. In the early 17th century, an Italian mathematician named Galileo Galilei challenged this reality. Using a simple tube of glass, he turned his attention upward to interrogate the heavens. Galileo replaced abstract logic with physical evidence, shifting the focus of human inquiry from the word of ancient authorities to the direct observation of the natural world. Born in Pisa in 1564, Galileo abandoned his father's plans for him to study medicine. Instead, he became obsessed with the precision and logic of mathematics. He entered a world governed by the physics of Aristotle, who claimed that heavy objects fall faster than light ones. It was a theory accepted as truth for 2,000 years, simply because it sounded logical. Galileo tested this logic using rolling ball experiments on inclined planes. He measured the descent of various objects and proved that spheres of different masses actually accelerate at the exact same rate. By requiring the universe to prove its laws through math and repeatable experimentation, Galileo created the template for the modern scientific method. In 1609, Galileo built a version of the spyglass, a device originally intended for military surveillance. He was the first to point this tool at the night sky to record what he saw. His sketches revealed that the moon possessed mountains, valleys, and rocky craters. This evidence contradicted the long-held belief that celestial bodies were smooth, perfect, and divine spheres. He also observed dark spots crossing the surface of the sun. These sunspots proved that the sun was not only rotating, but was also physically imperfect. In 1610, he discovered 4 points of light orbiting Jupiter. This was the first visual proof that celestial bodies could revolve around something other than the Earth. These physical imperfections dismantled the doctrine of a flawless, Earth-centric universe, turning Galileo into a celebrated, if controversial, figure across the continent. Galileo's data supported the theory of Nicolaus Copernicus, who had argued decades earlier that the Earth orbits the Sun, a concept known as heliocentrism. This explains his critical proof, the phases of Venus. As Venus orbits the Sun, it changes from crescent to fully illuminated from Earth. In the Earth-centered model, trapped between us and the Sun, a full Venus is geometrically impossible. This was the smoking gun. Galileo had the evidence to prove the Earth moves, putting him on a collision course with the Roman Inquisition. In 1616, the Church officially declared heliocentrism foolish and absurd. Galileo was warned to stop teaching it as truth, forcing him into a decade of silence. He returned to the subject in 1632 with his book, Dialogue Concerning the Two Chief World Systems. It was written as a conversation between 3 characters debating the structure of the universe. Galileo made a political error by placing the Pope's own arguments into the mouth of the book's foolish character, Simplicio. This public humiliation cost Galileo his most powerful protector. In 1633, the 69-year-old scientist stood before the Inquisition. Facing the threat of torture, he was forced to choose between his life and his discoveries. Galileo knelt and read a forced recantation, detesting his own work as heresy. According to legend, as he stood up, he whispered a final defiance, "And yet it moves." The Church sentenced the father of modern science to life under house arrest, effectively attempting to silence the truth of the moving Earth through institutional force. Confined to his villa and eventually going blind, Galileo spent his final years secretly writing a new book on kinematics and the physics of materials. This manuscript, Two New Sciences, was smuggled to Holland for publication. It provided the mathematical foundation that Isaac Newton would use decades later to formulate the laws of gravity. While Galileo was wrong about some things, including his theory on ocean tides, his legacy rests on his rigorous methodology rather than the perfection of every result. Humanity eventually named a spacecraft in his honor. In 1989, the Galileo probe was launched to explore Jupiter, navigating the solar system using the same principles of motion he first identified in his villa. Galileo established a world where observable evidence carries more weight than institutional dogma, allowing future generations to look at the stars and see the universe as it actually is.